Let's do section 10.4 at page 515, exercise 48, which reads, find the sum of the telescoping series. And for exercise 48, our series is the summation from n equals 1 to infinity of 4 over 4n minus 3 times 4n plus 1. Now, example 7 says that we want to start by writing the nth term, but we want to write that nth term in terms of two separate fractions so that we can really see the telescoping nature of this series. So we're going to go over here and do our partial fraction decomposition. So we've got 4 over 4n minus 3 times 4n plus 1. And that's going to be equal to a over 4n minus 3 plus b over 4n plus 1. And when we use partial fraction decomposition, we need to get a common denominator here of 4n minus 3 times 4n plus 1. So that's going to be a times 4n plus 1 plus b times 4n minus 3. And that's still going to be equal to 4n minus 3 times 4n plus 1 with the 4 in the numerator. And of course, we can cross off the denominators. And then when we're trying to figure out what a and b are, we choose values for n that's going to make the math simpler. So I'm going to start off by choosing n is equal to 3/4. So I'm going to have 4 is equal to a times 4 times 3/4 plus 1 plus b times effectively 0. And this is going to give me 4 times a is equal to 4, or a is going to be equal to 1. And then my other good choice for n is going to be -1/4. And then we're going to have 4 is equal to this time a times 0 plus b times 4 times -1/4 minus 3. And this is going to give us -4b is equal to 4, or b is equal to -1. So let's write out our nth term here, and we're going to have 1 over 4n minus 3 minus 1 over 4n plus 1. And example 7 says that we need to find a general formula for the nth order partial sum, and we should probably start by writing out some of the lower order partial sums. So for instance, S1, when n is equal to 1, I'm going to get 1 minus 1/5. If I let n be equal to 2, the second order partial sum is going to be 1 minus 5. I'm sorry, 1 minus 1/5 plus 1/5 minus 1/9. And that's going to give us 1 minus 9. If we go to the third order partial sum, we're going to have 1 minus 1/5 plus 1/5 minus 1/9 plus 1/9 minus 1/13. And the fact that these inside terms here end up canceling is where the telescoping part of telescoping series comes from. And this is going to give us 1 minus 1 over 13. And I think we can see a pattern evolving here so that we could say that a general expression for the nth order partial sum, Sn, is going to be 1 minus 1 over 4n plus 1. Now, in order to find what the sum is, which is s, example 7 tells us to take the limit as n goes to infinity of the nth order partial sum. And this is going to give me the limit as n goes to infinity of 1 minus 1 over 4n plus 1. And when we substitute in n equals infinity, we're going to get 1 minus 0, or we're going to get that the sum of this series is 1.